En este tema,
In this lesson we solve the problem of determining if a vector belongs to a subspace, that is, the problem of a vector belonging to a linear subspace. First, the notation should be clarified somewhat. The subspace generated by the columns A1, A2, An, of a matrix A, will be denoted as A row. A is a matrix, and the row is a Greek letter, which we will use to refer to real numbers. Then, the set A row is the set formed by all possible linear combinations of the columns of that matrix A, and the rows, row 1, row 2, row n are the coefficients. Then A row represents a linear subspace. We can also use another notation, which is L of A1, A2, An, where the Gothic letter L, that you have there, refers to linear, that is, with that, we are expressing that they are all vectors which are linear combinations of the vectors A1, A2, An. Well, to study the problem of knowing if a vector v belongs to the linear space generated by the columns A1, A2, An, of A, what we are going to do is to express this relationship in three different ways, to see it from the point of view of the orthogonality. For this, what we do is the subspace L of A1, A2, An, instead of simply expressing it so, we see it as the orthogonal of the orthogonal. We know that the orthogonality operation is an operation that has the property of idempotence, so that, when applied twice to a subspace, it becomes the initial subspace. So, the second form, actually what is telling us, is that the vector v it is perpendicular to the orthogonal subspace of L of A1, A2 to n. This means that we have expressed linear subspace membership, of three different ways. The first, which is the classic, considers the subspace as the set of vectors that depend linearly on some generators or basic elements. In the second, the property of idempotence has been exploited, and we have seen that a vector subspace is the orthogonal to its orthogonal. In the last one, what is done is that a vector belongs to a subspace, if and only if it is perpendicular to its orthogonal space. This last form is the one that tells us how we should answer the question of whether a vector belongs to a subspace or not. The idea is as simple as follows. First, we calculate and we get the subspace orthogonal to the given subspace, and once we have obtained it, we simply check if that vector that we want to know, if it belongs to him, is or is not orthogonal to that subspace. If it is, it belongs to it, and if not, it does not belong to it. Let's see it, with an example. Imagine that we have a matrix B, and that we want to know if its row vectors belong to the subspace generated by those two vectors, to the A row subspace, where A is the matrix with two column vectors, that is, it is a subspace of dimension 2. So, we want to know if the row vectors of matrix B belong to the subspace A row. What does the method tell us? The first thing you have to do is to get the subspace orthogonal to the subspace A row. How is it done? Well, we introduce the two vectors in the algorithm, the two column generators of that subspace, that is, as they have been introduced in the lower part of the transparency, the vectors 1 0 0 -1, and then, in the iteration 2, the 0 0 -1 1, which are the vectors that generate the subspace. Then, we pivot and we get the final table, which is the orthogonal subspace to the subspace generated by those vectors. These generators are obtained simply by eliminating the vectors w, with which we have pivoted. Eliminating the vectors in yellow, which are w, and staying with the vectors in beige, or in light brown.
y quedándonos con los vectores en beige claro, o en beige o en marrón claro. Entonces, eso por
Further,
un lado.
we are
Pero
going to use
nosotros
the yellow vectors
también
too, that
tenemos los
is,
vectores
the
amarillos.
vectors that we had to
Entonces,
theoretically eliminate,
numéricamente
they are put
vamos a ir
there,
a continuación
into another
del esquema tal y
matrix,
como está
like that of
en
the
el diagrama.
figure, and now
Y
we're
ahora
going
vamos
to
a
take matrix B, which has the
coger
vectors
estos
that we
vectores
want to know if they
y
belong or
identificarlos
not to that subspace,
y
and we
pertenecen.
multiply them,
Y
in
vamos a
front of this
multiplicarlos
matrix
por
that we
la
have
P de
obtained.
la matriz esta que hemos
If
obtenido.
we multiply the
Y
matrix
multiplicamos
B,
la
by
matriz
this
B
matrix, that we have
por esta
obtained in the
matriz
final
que tenemos en la
table,
tabla final,
placing properly
colocando
first,
adecuadamente
the vectors V,
los vectores
which can be
x,
used to
y
pivot, and then the
Z,
W,
los que han sido
that they have already been
llevados a
used
la
to
unidad,
pivot, we
se
get the
obtiene la
matrix
matriz
you have at the
esta
end,
final, que es la
which is the
matriz C.
matrix C. What happens
¿Qué
with this
ocurre con esto?
matrix?
Pues muy sencillo.
Well, very
Si
simple,
al
by
multiplicar,
multiplying these
dijéramos,
vectors,
estos
by
vectores
the first
por las
two
dos primeras
columns,
columnas,
we
por
obtain the
las dos
two
últimas
columns,
columnas,
that
obtenemos
appear in
las
brown.
columnas que aparecen en
What
marrón.
happen?
Claro.
As that indicates then the
¿Y qué
first two
ocurre?
vectors,
Que
having two
como
zeros in the
eso
corresponding
indica
rows,
que
what is
tenemos que tener
telling
dos
us,
veces, al tener dos
is that
ceros,
those vectors are perpendicular to their orthogonal subspace, that
lo
is,
que nos está
they
diciendo
belong
es
to the
que
subspace.
ese vector es
However,
perpendicular
the
a su
last two
ortogonal.
vectors,
Es decir,
whose
que son
scalar
vectores.
products give 1 3,
Sin embargo,
and
estos
minus 1
vectores
3, they are
que
not
tienen puntos
0,
escalares
and they had to be
1 3 y
0,
-1
in
3,
order them to
este
belong
0,
to a row,
este 0, estos
then,
dos
the
no
last two
pertenecen.
vectors do not belong to a
No
row.
pertenecen.
Finally, what
¿Y
happens with the rows in
qué
yellow?
ocurre con las filas
Well,
en amarillo?
they give us
¿Qué
the
ocurre con las filas?
components of the two
Pues
vectors that
que
belong
nos
to the
dan las
subspace, with
componentes
respect to the
de todas
generating
estas
elements that
características.
appear there, that is, with respect to the
Espacio con
basis.
respecto a los
So,
elementos
the
generados.
first vector we know that since it has the first two
Entonces,
columns
el primero
0, it
sabemos
belongs to the
que al tener las
subspace,
dos primeras
and
columnas
having as
0,
its last
va a
columns,
rellenar espacio,
in
y al
yellow,
tener como
1
últimas
and
columnas
1,
en amarillo
means
1 y
that,
1,
1 time the
y
first
esto
vector
por
column of the
la
matrix A row,
matriz
plus 1 by the second
esto por
column, gives us the vector this what we
ortogonal,
want to
nos da el
calculate.
vector este que queremos.
Similarly, the
Al igual
second
que el segundo
vector,
vector,
as it has
tiene
zeros in
ceros
its first columns, the
en
first
las
two
últimas columnas,
columns,
las dos primeras
it
columnas,
belongs to the
tiene estos ceros.
subspace A row and,
Y al pertenecer,
because it belongs,
puede interesar
then
saber
we may
cuáles
be
son
interested to know what the components
las
are.
columnas siguientes, que son
The next
amarillo y
two
azul,
columns,
nos dan
which are 1 and minus 1,
las,
give us that value.
los valores que
The
corresponden a los
values
dos
that
últimos vectores
correspond to the two
han
last
desaparecido
vectors,
porque han
no
sido
longer
multiplicados
have meaning,
esos
because if the
dos
vector
vectores.
does not belong,
Por
those
tanto,
values are
hemos
not the
visto
components.
cómo se
Thus,
puede saber
we have seen
que un
how you can
vector
know if a
es
vector belongs
perpendicular
to a
de una forma muy
subspace,
sencilla.
of a very
De hecho,
simple way.
podríamos
In fact, we could build a
construir una
black
caja negra,
box, where we could put in this
podríamos
black
meter en
box,
esa caja
this
negra
final
esta matriz
matrix,
final,
with its columns
con
ordered,
columnas
and
ordenadas,
when they give us a
y cuando
vector,
nos den un vector
inside the black
dentro de la caja
box,
negra,
we would multiply
meteríamos
by the
esta caja
first columns, that correspond to the vectors with which we have not pivoted. If the
y si
scalar
el profesor
products were
adecuadamente nos
0,
contestaría
we
que
would
el
answer that the
vector
vector
pertenece
belongs.
y los productos
If
adecuados
scalar products
contestarían
were other than
que
0,
no
we would
pertenece.
answer that it
Y
does not
además, en
belong,
caso de que
and in
perteneciera
addition,
a
if
estos
the answer is
espacios,
positive,
podríamos
we could,
multiplicar
using the last
multiplicando las últimas columnas
two
para
columns,
decir cuáles son
to
los
provide the
componentes.
components of this vector.
Por tanto, hemos
Therefore,
obtenido
we
un
have
método
obtained a
muy
very
interesante
interesting
que ha
method,
surgido
which has
precisamente
emerged
por esta
precisely
propiedad
after
de
exploiting the
ortogonalidad.
concept of orthogonality.